Hey folks, welcome to this new series on interview coding problems. I've always felt the best way to learn a coding language is to do a bunch of these coding problems because they will get you familiar with the data structures and how to use them. And I've become rusty with C++ because I don't use it day to day in my day-to-day coding life. So I thought might as well start with some coding problems, code them in both Python and C++, and let's see where it goes. Yeah, so I have got two series running right now. One is this, and the other one is PyTorch. So again, that is completely Python based. So I needed a change of pace, and that's why we are here. So let's select a problem to solve. I'm in lead code, and I'd like to check out, one of those questions that are asked in interviews because I feel that might be the most useful. So if I go to the discussion section and let it load. Let's check out the Google online assessment and let's check out, let's see, let's try with something of medium difficulty that's not too hard, at least for the first video. So let's go with this because this seems rather easy. All right, so let's see. So basically, we have to figure out the maximum level sum of a binary tree. Now, binary tree is one that has two nodes or rather two children for each node, at max two children. So in this binary tree, one has two children, 7 and 0, and then 7 has 7 and minus 8. So we need to compute the level ordered sum. So this is level 0, this is level 1, and this is level 2. All right, so basically for level 1, the sum is 1 because there's only one element. For level 2, the sum is, there are two elements, so it's 7 and 0. You add them up, becomes 7. And for level 3, the sum is 7 plus minus 8. I guess if there were two more elements here, we would add them up as well. So this is the level ordered sum. Uh, so basically, we return the maximum value, which is 7. All right, so the result should be 7. Why is it 2? Oh, okay. So you basically print out the level where the maximum occurs. Okay, so 1, so if root is 1, this is 2, 3, 7 occurs in level 2, so you return level 2. All right, this is a pretty straightforward question, at least to understand. Um, so let's think of how we will attempt this one. Now again, I'm not a coding genius or like I haven't done a lot of algorithmic coding problems, so uh, my approaches will be maybe a bit force-ish, and I will use simple approaches, and then let's see how far we can get with it. So immediately, what comes to my mind, because whenever I see level order, BFS comes to my mind. So I can basically do a breadth-wise search, and at each level, I add the elements or add the nodes up. And how do I keep track of levels? So first I'll attempt my solution in Python, and then I'll use a tuple where basically when I do my BFS, each tuple will contain the node and its level. So that way it's a bit easier for me to keep track of what levels I'm dealing with. I mean, I'm sure there might be more optimum ways of doing this, but let's do a BFS. So I'll do a level order transversal, and then I'll keep track of level by an index that I'll keep carry around. All right, so let's jump in. Okay, so let's see. Um, oh, let me first select Python, and of course, like I have an idea of how to do this because I have done problems like this before. But let's see how far we can get. So let me create a variable or a list where I will store the sum of basically the depth-wise sum, and then let me create a tuple or a list basically of tuples which contains basically my node and then the level at which it is. So let's say, so let me call root to be 0, and then the current sum of each node. All right, so now I will loop till there, like I'll keep on looping in a while loop while current is not empty. And then because we are doing, let's see, is OBS capturing this well? Yeah, okay. All right, so because we are, let's see, do I need to zoom in a bit more? Yeah, this is a bit better, right? Okay. Because I am doing BFS, I want to pop out from the beginning because elements get added will be appended at the end. So if I pop out from the end, it will become depth first search. If I pop from the beginning, it becomes BFS. So I'll do that. And then basically I will see if I'll check if I'm at the same level or not. So if I do element of 1, which refers to this, if this is um, equal, then just keep on adding the values. Let's see, element 0 dot, the value is stored in dot val, so well, else I will let me type it out and then I'll explain what I'm trying to do here. I'll append basically temp sum, and then temp sum is equal to element 0 dot val. All right, so basically first I check the level. Now if the level is equal to the length of my depth, that means I'm still probing the same level. So for example, for the root, the level is 0 and the length of some depth is also, because there's nothing, it's 0, so it will just add this element. Let's say we were at level 1, so all my elements would contain a 1 over here, and then since some depth would already have the value of root inserted, its length is also 1, so I will keep track of that. If there's a mismatch, that means now we are probing the next level. So we need to append whatever current temporary sum we have in our this depth capturing variable. And then I reinitialize my temp sum to be the first value of at the new level that we encountered. All right, so that takes care of that. Now I need to, in my queue, which I have called current, I need to add in the left and right branch. So if it exists, then just add it up. So, and again, like we are adding a tuple, so, and its level would be the level that we have seen plus 1, right? And that's it. So now let me copy this for the right branch. All right. That's it. So the reason why I use tuples is because I like Pythonic ways of doing things, and Python is so tuple friendly, so makes sense to approach it. So okay, all right. So now we have the list of some depth. So all we need to do is return the location of the maximum element. So I'll do dot index, and then I'll find the maximum of some depth. All right, yeah, this looks good. Oh, all right. This has to be outside. Okay, this looks kosher. Let's run it. Let me see how it comes about. Oh, we got a wrong answer. Okay, let me first resize it a bit. Good. All right. I was expecting an output of 1. Well, expecting output of 2, and it gave me 1. Okay. Let's see. Let's print out what my sum of depth contains. So it should contain three values, right? So because for the first level, let me go back. So for the first, at level 1, there is 1. For level 2, there is 7. And for level 3, there should be 1. So I see there is something weird going on here. First of all, there should be three values, so which kind of indicates that the last for the when we exit out of this current, our temp is not added in. So I see. So now let me just so when I exit out of this while loop, I still need to add in the temp one last time. So I'll just copy paste this. All right, let's see if this makes sense. Huh, my sum of depths is a bit weird, but hmm. So let's see what's, oh, right. Uh, since I'm checking the right branch, I need to also make sure the right one is added in. I messed up here, and let's run it. Huh. All right, let's try to figure out where we went wrong. Oh, in this else branch, I am not. Oh, I thought I had a code of updating. All right. Third time is a charm. Good. At least our sums are working correctly. But now the index is wrong, and I see the reason why. Because we started with a slightly weird indexing where root was 0, but the question demanded that root was +1, so there is an offset. So I just add a +1 in my return statement, and then all right, it worked out. Let me quickly submit it and see if I get the right result for everything, and boom, yeah, we get the right result. As you can see, like, I mean, we're not doing too good on the statistics, but who cares? Okay, well, it's important, but we don't care about it right now. So, all right, let me quickly walk you through what the code is about, and then we'll try to code in the C++ solution. So first, I have a variable that keeps track of the sum of depths. So, and then I have this queue, which is in Python, which is right now a list of tuples. And the tuple, the first element is my node, and the second element is the level at which it's occurring. And then I also have like a temporary sum, which contains level-wise sum. All right, so in this while loop, I basically pop out the first element. That's why it's pop 0. And then basically I check if we're at the same level. If we're at the same level, I keep on appending or adding to the temporary sum. If we are at a different level, I add the temporary sum to the sum of depths, and then I reset it. And then again, like in my queue, I add the left and right nodes. Finally, I add the sum depth again, add to the sum depth again, and then basically find the maximum where the maximum occurs. So pretty straightforward solution. Now, I'm sure there are like more optimized way of doing it, and we'll look at other people's solution as well. But let's try to code this up in C++. Now, again, I understand there are multiple ways of doing this in C++, but I'd like to rely a lot on the STL libraries because I'm trying to familiarize myself with them. And then I would like to also basically translate this exact solution in C++. So I want to use tuples. I want to use basically the same kind of things, exact same logic. So we will do BFS and we will use tuples. So that's going to make it a bit interesting. So let's see. How do I actually go into, all right, C++ is here. Great. Okay, so let me begin. So first of all, I have to make a queue. So I do queue, std queue, and then this queue would be made of tuples. Now, if I had to give an interview, I would never type in C++ because it's so verbose and it requires like it's half the time is just spent in typing out variable declarations. So this tuple would have a tree node and an int. Note, and the reason for this is the fact that I am trying to replicate the exact same Python solution in C++. So I'm not trying to optimize it for other things. And that completes the tuple declaration. That's my queue. And oh, yeah, that's the template. And then I call it current. Same variable naming. And then to store my sum of depths, I'll have a vector sum depth. All right. Then also the temporary sum variable that we talked about. And now let's fill in. Um, so let's create a tuple. Wow, I guess I'll be using this quite a lot. So let me just copy this. The beginning tuple where I store in the root and level. And then I push it back this begin. All right, good. So 5 lines just to do a simple work. So we've created the queue. The queue would contain tuples, and the tuples would be of the type node and int. Then I have this vector of which will carry the list of depths or sum of depths, and then I have my temporary variable to capture the sum, and then I fill in my initial state in my queue, which is just the root node and its level, which I've set to be 0. All right, so now we will have our while loop, and the while will keep on going till current is not empty. Great. Now I want to pop out the elements from my queue. So let's use auto because I do not want to type out everything every time. Okay, so this grabs the first element and then I pop it out. And then I need to figure out what the elements are. So I will first get them. So for obtaining the elements from a tuple, you have to use std get. So this is the first element. So now the data type auto would be std tuple because from the queue we are popping out its elements, which are tuples. So I pass in this std tuple here, and then I have to use std get to get the first element. To get the second element, same thing. Great. So now that we have our elements, now we will do the same kind of if-else check that we did before. Because second one is the one that contains the level. So we will see if we are the same level, then append to the temp sum. So now notice I use the arrow symbol because we are dealing with tree node pointers. That's why. And val is the int object that stores, int variable that stores the value. So, and else, then if it's not the case, then basically just append. So I will do append to sum depth. Okay, sum depth dot push back and temp sum, and then we reset temp sum to be, oh, how's it coming out? Okay, we reset temp sum to be the same thing, the value. All right, great. Now we need to add the left and the right nodes. So if first left is not equal to null pointer. So just a tip, never use null or zero for null pointers. Just use the keyword null pointer. So here now, okay, now we need to create a tuple and then append it to our queue. So we will do std. I'll just copy this bit of code. Std tuple, the kind of tuple, and then I'll pass in first left, and this is second plus one because I'm adding the level. All right, and the same thing we need to do for right. So I'll just copy paste, and I will do it for right first, right. Oh, and we need to push it back. So uh, current dot push next. Same thing here. Boom, done. Okay, so this completes the if, this completes the while, and if you remember last time when we messed up, we had to push back the value into some depth, the last value. So I'll just add that statement here. Now, finally, we need to return the distance, right? So where the index occurs. I apologize for the background noise. There's a lot of traffic on the street. Okay, so to do that, like I said, I'm relying heavily on std functions. So what I will do is I'll also make use of the distance function. Now, distance function takes 2 pointers because we are dealing with the container, because we are dealing with the vector container, because that's the one that contains depth. I pass in its beginning iterator. So well, I can also pass in the constant iterator, but it really doesn't matter. And then I need to figure out what is the maximum. So you can use max element to figure out what's the maximum. For that, also you have to give it the begin and end iterators. So begin and end. Awesome. And then because again there's an offset, we print this out. Let's run it. Let's see if we made any errors. It looks good. Let's run. Ooh, the error is undeclared identifier tree node. Debugging C++ is a pain. It's in line 15 here. Okay, stdq. Oh, the N is capital. Let me see if I made this error anywhere else. I made this error everywhere else. So I will. Right, let's run this. Current.pushback begin. Oh, it's not pushback. It should just be push because it's a queue. Wow, I'm making a lot of errors. Okay, good. Now let's submit it and see if we are able to get it to work. And yeah, good result. Runtime is decent, but we're using a lot of memory. Yeah, that's that kind of whenever you're doing BFS, it expands out. So I can see why that's true. All right, so let me just quickly walk through the code. So first of all, it's the same thing. First, we have a queue, which is made of tuples of nodes and int. And then I have a vector, which is basically stores sum of levels. I heavily used auto to grab elements from the queue, which are tuples. I use std get to get the first and the second elements. And then I check for the depth. If depth's the same, keep on adding. If it's not, append to the sum depth variable. And then I check for null pointers to add the left and right nodes with incremented levels. That's it. And at the end, I used std distance to compute. So first of all, I compute the maximum element. You can do that using std max element. And then to figure out the distance, I use std distance. Now, you don't need to use this. there are much like a brute force would be to run a for loop, find the maximum element, and see its and then its location. Now, well, one for loop would do the job. Uh, I think the complexities are the same. It's just that it's elegant and you can do it in one line. That's why I use this. But yeah, there's practically no difference. Okay, so that pretty much wraps this video. But before I end, I'd like to have a look at the solutions that other folks have. So let me go there. Let me see if I can put, yeah. All right, okay. Let's see. Some people have tried BFS, BFS. Um, Let me check out a couple of solutions. Um, Also some Python. Yeah, seems like everyone is using BFS. Okay, let me just basically look at these solutions. Uh, well, this is much more elegant. As you can see, there's no tuples hanging around. And the way that this person is doing, figuring out the levels, let's see. They have a queue, they push in the root, they have a for loop, and oh, I see. So they keep pushing things in this for loop. So, all right, so at any given moment, the queue only contains the element of a level, like because this is computed in the beginning. So n only contains the number of elements for that particular level, and they keep appending to the list. Uh, and so this n sees the new elements at the next iteration of the while loop. That's clever. That's clever. I see how that's useful. And then they are checking for the sum inside the while itself. Oh, pretty neat. Pretty neat. So basically, at each while iteration, they check the whole level. So this for loop works at a particular level. It checks for all the things at a level, and then the same thing with the if condition, and then the while goes to the next level. Oh, that's a pretty neat solution. I think that's pretty good. Good job, Scientific. All right, so I think that's the end of this video. I will keep making more as I, try out different problems. Hope to see you guys again next time. See you.